Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on inverse functions. The last time we were together, we studied the graphs of 6 trigonometric functions and reviewed the terms domain, range, and period. Today, we will learn how to define and sketch inverse trigonometric functions. Are you ready, students? Let us begin the lesson. Before we look at inverses of trigonometric functions, let us review several important facts. Remember, students, that an inverse function is not a reciprocal. For f, a one-to-one function, and f inverse, the range of f equals the domain of the inverse of f. Similarly, the domain of f equals the range of the inverse of f. If a, b is an element of f, then b, a is an element of the inverse of f, and vice versa. The graph of the inverse of f is obtained by reflecting the graph of f in the line y equals x. Because all trigonometric functions are periodic, each range value can be associated with an infinite number of domain values. As a result, no trigonometric function is one-to-one. In order to resolve this problem, we must restrict the domain of each function. Students, let us start by studying the inverse sine function. We can see in this graph that sine increases from -1 to 1 in the interval of -pi over 2 up to pi over 2. This gives us our definition of the inverse sine or arcsine function. The arcsine function is defined by arcsine of x equals y if and only if x equals sine y, where y is greater than or equal to -pi over 2, but less than or equal to pi over 2. The domain of the inverse sine function x is the closed interval negative 1 up to 1. The range is the closed interval negative pi over 2 up to pi over 2. We already know that cosine of x is not a 1-to-1 function. However, we can see in this graph that cosine is invertible in the interval of 0 and pi. If we restrict x to this interval, then for every y in the interval of negative 1 and 1, there is a unique x such that cosine of x equals y. The inverse cosine or arccosine function is defined by arccosine of x equals y if and only if x equals cosine of y for a value of y that is greater than or equal to 0 and less than or equal to pi. The domain of the inverse cosine function x is the closed interval negative 1 up to 1. The range is the closed interval of 0 and pi. The tangent of x is invertible when x is restricted to the interval of negative pi over 2 and pi over 2, as seen in this graph. Therefore, the inverse tangent function, or arctangent, is a function that assigns to each real number x the unique number y in the interval of negative pi over 2 and pi over 2, such that x equals tangent of y. The domain of the inverse tangent function is the interval of negative infinity to infinity. The range is the closed interval of negative pi over 2 up to pi over 2. The definitions we have just learned tell us that the inverse sine function assigns to each number x in the closed interval of negative 1, the unique number y in the closed interval negative pi over 2, pi over 2, such that x equals the sine of y. This means that the inverse sine function of sine of x equals x if x falls between or is equal to negative pi over 2 and pi over 2. Similarly, we can determine that the inverse cosine function of cosine of x equals x if x falls between or is equal to 0 and pi. Finally, we can also determine that the inverse tangent function of tangent of x equals x if x falls between negative pi over 2 and pi over 2. Remember, the pi over 2 is not in the range of the inverse tangent function because the tangent of pi over 2 is undefined. Students, let us try some activities to test our understanding of the subject matter. Please find the exact values of each of the following expressions. Try not to use your calculator or your trigonometry table. You may begin now, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I hope you did not find that activity too difficult. Please compare your answers to these. If the inverse tangent function equals the square root of 3 over 3, then the tangent of theta equals the square root of 3 over 3. In using a special triangle, we know that the two sides are the square root of 3 and 3. Thus, we can use the Pythagorean theorem to calculate our hypotenuse as 2 times the square root of 3. With these values, we can see that sine of theta equals the square root of 3 over 2 times the square root of 3. This gives us theta equal to 30 degrees, or pi over 6. Therefore, the inverse tangent of square root of 3 over 3 equals pi over 6. If the inverse sine function equals the sine of 5 pi over 4, we can write it as the inverse sine function equals negative square root of 2 over 2. Therefore, sine of theta equals negative square root of 2 over 2. Using special triangles, we can calculate that theta equals negative 45 degrees, or negative pi over 4. The inverse cosine function of the tangent function of negative pi over 4 can be written as the inverse cosine function of negative 1. This is because the tangent function of negative pi over 4 is equal to negative 1. Therefore, the cosine of theta equals negative 1. If we use our cosine graph, where y equals the cosine of theta, we see that when y equals negative 1, theta is equal to 108 degrees, or pi. Were these your answers, students? If so, well done. The definitions of the inverse cosecant, secant, and cotangent functions are given as follows. Y equals the arccosecant of x if and only if x equals cosecant of y, where y is greater than or equal to negative pi over 2 and less than or equal to pi over 2. Y cannot equal 0, and the absolute value of x must be greater than or equal to 1. Y equals arcsecant of x if and only if x equals the secant of y, where y is greater than or equal to 0 and less than or equal to pi. Y cannot equal pi over 2, and the absolute value of x must be greater than or equal to 1. Y equals arc cotangent of x if and only if x equals the cotangent of y, where y is greater than 0 and less than pi. X is any real number. Students, please look at these three graphs. You were just given the definitions of the inverse cosecant, secant, and cotangent functions. Can you use these definitions to identify which graph belongs to which function? When you think you have the answers, share your choices with a classmate.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Graph number 1 is the arcsecant of x. Graph number 2 is the arccotangent of x. And graph number 3 is the arccosecant of x. Great work, students. If you had any difficulty, I am sure teacher will be happy to help you after the lesson. Students, today we have learned how to define inverse trigonometric functions by restricting their domains. We have also studied the graphs of the inverse trigonometric functions. In our next lesson, we will look at more graphs of trigonometric functions. Until next time, thank you, teacher. Thank you, students.